Hey, welcome back to my channel. My name is Gina. In my previous video, we looked at how to solve a linear system by reducing the augmented matrix. We look at 3 examples. One example, the system has unique solution. The second example, the system has no solution. And the third example, the system has infinitely many solutions. If you haven't watched the video, I'll also put the link up there. So in this video, we are going to discuss how to determine whether a system has unique, no solution, or infinitely many solutions. So if we write our system of equation as a coefficient matrix A times the variable columns X, and this equals to vector B, we can get 2 cases. The first case is when the system has no solution. When the system has no solution, then the reduced form of the augmented matrix has a pivot in its last column, which means we'll find a pivot in the vector B. And if we find a pivot in the last column, then there's a row that is in the form of 0, 0. So on the left we have 0, but on the right we have a non-zero pivot. So it is not consistent because the last row says 0 equals to a non-zero number. And the second case is when the system is consistent. When the system is consistent, we can further classify them as when the system has unique solution and when the system has infinitely many solutions. If the system has unique solution, then in the reduced echelon form, the coefficient matrix A has a pivot in every column. How about when the system has infinitely many solutions? Remember from the previous video, in the third example, we have the second and the fifth columns that don't have a pivot. So we name x2 and x5 as free variables. So when a system has infinitely many solutions, if we reduce the coefficient matrix, A has columns without pivots. Now let's look at some definitions. Let A be any matrix. Then the rank of A, we can also denote that as Rk of A. We define this as number of pivots in any reduced echelon form of A. And we define the nullity of A as the number of columns of A minus number of pivots. So it is the opposite of the rank of A. I named the R for the rank of A. And a quick remark, since we can only have one pivot in a row and in a column, so for any matrix A that has size of n by n, the rank of A, R, must be smaller than or equals to number of rows, and it has to be smaller than or equals to number of columns. So the theorems are as follows. If we let A be an n by n matrix, then A times the variable column X equals to B is consistent if and only if rank of A equals to the rank of the augmented matrix. For example, if we reduce the system into reduced echelon form, so we have a pivot here and a pivot in the second column. Then on the left, this is my matrix A in reduced echelon form. And to the right of the vertical bar, this is my vector B. So what is the rank of A? In matrix A, we have 2 pivots, so rank of A is 2. However, the rank of the augmented matrix, here we need to include the column next to the vertical bar. So here we have another pivot. So rank of the augmented matrix is 3. So rank of A does not equal to the rank of the augmented matrix. So this system has no solution. The second theorem says, given that rank of A equals to the rank of the augmented matrix, and let's name this as R. If R equals to n, remember that we let matrix A be size of n by n. So if the rank equals to number of columns, then the system has unique solution. However, if the rank is smaller than the number of columns, so we have at least one column that has no pivot, then we can name the variable as the free variable. So in this case, the system has infinitely many solutions. And that is the end of the video. A quick summary of the video. When we have a linear system, the system can either have no solution, unique solution, or infinitely many solutions. It has no solution when we reduce the matrix, and in the last row we have 0 equals to a non-zero number. And the system has unique solution when the reduced matrix is consistent and number of pivots of the coefficient matrix A equals to its number of columns. And lastly, a system has infinitely many solutions when its number of pivots is smaller than number of columns. If you like my videos, please like and subscribe, and I'll see you in the next video.